Hello everyone and welcome back to DTS Programming. My name is Daniel and today I'll be presenting my Project 1 for GPE340 Programming with Game Engines. And this is my root motion character controller. Going into the guidelines, some techniques that we used from the lectures in this course. Character must be controllable using keyboard and mouse, using input get axis and input manager to handle that input. Character must be affected by gravity and be able to physically interact with the world. The scene must contain geometry that lets you test the character's behaviors, and you must implement a mechanic of your choosing that relates to character movement, for instance, something like a crouch or a sprint or dodge roll system. So moving right into my project, this is my game, Unnerved Assault Torrent. So for my game, I brought in this character sprite, and I got that off of the Unity Asset Store. So you can see here's the package that I got off the Unity Store. Sci-fi NPCs from Chayako 3D, aka CGI. I also brought in quite a bit of animations for this project. Most of these were brought in from Mixamo, and some of them came with the NPC package. So for this project, we were using root motion to do character movement. For root motion, it ties the animation with the motion, so it is good to use root motion if you have complex movement or if you want more accurate movement from your character sprite. And so taking a look at that, see what I have here is an animation blend tree. This basically takes in a bunch of animations, and depending on the parameters that you give it for the X, Y coordinates, it will blend the animations between those. And so we can take a look here. If we play this animation, my character here is showing just the idle animation. If we give it horizontal value, he'll begin to move sideways. And he'll go into a run at full horizontal input and also in the negative direction. And as I'm moving that, you can see this red dot moving around. That's kind of an indicator of where your controller would be. Vertical input, walk and sprint, walk back, sprint back, and then you have diagonal. So taking a look at that from the code side, if we go down here to our player movement, I've created two floats here, which store the input for the horizontal and the vertical axis. Then I create a vector3 variable called input, and I store a new vector3 passing in the value from the horizontal axis, 0 on the y, and the value from the vertical axis. I then make a copy of that input, and I clamp the magnitude on the input to 1. This kind of gives it a normalize. And then I multiply the input times equal the player movement speed, and that gives me direction plus speed. Then down here, I create parameters in the animator, and this tells the animator how to move my character using the horizontal with my input on the x-axis and the vertical with my input on the z-axis. And these next two fields are actually damp times. What this does is make the animation transition a little smoother, and the character doesn't snap as hard when you go from one animation to the next. And that is, of course, over time.delta time, which is frame rate dependent. So if we go back in the project, you can see these parameters that I have here, horizontal and vertical. These are the parameters that are also listed here. And so this lets the animator know which way to move horizontal, which way to move vertical, given these values, and controlling the proper animation based on those values. As another part of this project, we were told to speak to how the inverse transform direction works. So as you can see from my note here, this converts direction of world space to local space. And so basically what this does is, if I run the game with that line not commented, no matter how my character is oriented, he's going to move relative to world space direction. So I can show that. So going to my game, you can see that as I have the inverse transform direction activated, when I push my W key, I'm going to move in the forward direction. But if I turn around and push the W key, I'm going to continue moving in that direction in world space. And this is the S key. If I turn around, I will continue moving in that direction. and so it converts world space to local space. We were instructed to make top-down games, and so for a true top-down, those controls would feel more natural. But in my case, I made some stylistic changes, and I prefer to have the controls do the same thing no matter which way I'm facing. In this project, we were also tasked to rotate the character towards the mouse. I did that with a raycast. We'll go over my code first. So here I created an instance of a ray that goes from my main camera down to a screen point, and that screen point is my mouse position. Here I check if my raycast from the camera returns any hit info. It has an infinite length and is checking for info return from my mouse tracking plane, which is my defined layer mask, which I've added up here. On this next line, I create a variable called direction. It's set equal to the hit info point of my raycast minus my transform position. In this line, I lock my direction Y to 0, so there's no tilting as I move the mouse around the player. I normalize that to a value of 1, and then I take my transform forward of my player and I set it equal to the direction of the mouse. So going back into my project, you can see that I set my mouse tracking plane, which is my layer mask, I set it to the ground, and that layer was defined up here. I added ground in, and if I click on my scene view and click on my terrain, you can see that it has been defined as the ground layer. So anywhere my mouse is touching the ground, my player is going to follow. So I'm casting a ray from my camera out infinitely into the world. It's returning a hit point from my ground, and then it's setting the transform of my player to look towards that point. And if I go off the map, see nothing happens because it's not tracking any points. For the next objective, we were tasked to create a follow cam. So here in my code, I have a separate follow cam script. I have my private variables declared up here. One to store a player transform, one to store a vector 3 offset, which I'll explain in my project. And this third one is a smooth speed, and this all just controls camera movement. In my fixed update, I have a vector 3 called desired position. It's going to take the player's position and add it to the offset. I then have another vector 3 called smooth position. This is a linear interpolation between my camera's transform position, the desired position calculated here, and that's going to happen over the smooth speed times time.delta time. So this just means that the camera is going to move from one position to the next position within the parameters of the smooth speed. And finally, I take the camera's transform position and set it equal to the smooth position. So heading back into the game, you can see I have my camera here. So what I did for my project is I set it to orthographic. I was kind of going for isometric type top-down. So you have your standard orthographic settings here. Going to my script, you see my player transform. I passed in my sci-fi player. We got offset values for the camera. This is my vector 3 offset. So you see I can move the camera left and right, up and down, and up and down on the Z. With the smooth speed here, I got it set to 2.5. You can do 1, and you see that goes much faster. If we move the character, that smooth speed just kind of determines how fast that camera's going to move. That floating effect to catch up with the player. And so when I set that back to my desired 2.5, the camera tracks a little better, doesn't take as long to catch up. So I'm going to go ahead and run through this real quick to show some features that I've added in. Of course, I have my sprint, my side-to-side movement, I have collision, elevation, I can run up these hills, See here I have barriers. I added those in for the sake of showing other features, and so I have my crouch, shoot, and I have my prone. Added in a prone crawl. That took a little longer than expected. Anyway, if we go to our scene, zoom in on the character. You can see I have a capsule collider and a rigid body on him. If you look at my sphere collider here, standard height set to 2. If I go back to the game, go down to crouch, go down to prone. As you can see, if you watch my collider, 0.25 for the center of the collider, and the height is set to 0.6. If you look at the scene and edit collider, you can see that I shrunk it down. So when I go into a prone position, my collider shrinks, and that is what allowed me to get underneath this, which definitely has a box collider on it. And so I had to do that in code because I couldn't figure out how to make it change with the animation. And so when I go into prone, my collider shrinks, and again, you can see that in the game. If you watch the center and the height, as I get up, you see they return to the normal values. I've added in a jump, as well as a dodge roll. But what I haven't added in is actual jump physics. And so my character doesn't elevate just yet. I also have a running shoot animation. And I can interact with objects. Colliders on the buildings. Motion in all directions. Running back at angles. Running forward at angles. Running sideways and running the opposite way. Kneel, prone, with all the proper transitions. So as you can see, I'm not an artist, I'm not a designer. I made a very simple level, added some elevations, added some objects to kick around, little obstacle to go under. I got my scene from the asset store, and that's the isometric survival level pack from Reburu Game Studio. So finally, taking a deeper dive into my code. Here at the top you see I've placed my headers. I have tooltips for all my variables. I haven't done anything with health yet, but I have the values ready to go. Everything is private for encapsulation. Set max health, current health value, and my player movement speed. These are all player values. For my action triggers, I've declared a string array here called player action, and then I have a key code array called map key. That's for animation triggers that fire off one time, such as holding the button for shooting or for my jump and roll. And then I have the same thing but with toggles. So I have an array of toggle actions, an array of toggle keys, and these are for actions such as crouching and going into the prone position. And so if we come back over to my code, we can see here we have action triggers, and I only set this up so that it would allow designers to come in, put in the action that they wanted, set a parameter here, type in the name of that parameter, map it to the corresponding key, and then you can switch around keys for any action as you please. And then if you want toggle actions, it's the same thing. So when you press these keys, they go from true to false, and these actually toggle. They'll go to true on the first button push, and then they'll go to false on the next button push. So in my code, we'll take a look at that real quick. Here we have our animation action triggers. I passed in my string array and my key code array. So for this line, it's kind of funny. I learned about ternary statements. So what this line of code is saying is if the mouse key is being held down with the gate key, then this trigger boolean value is going to be true. Otherwise, or else, so this is like an if-else statement. If this is held down, statement is true, else it's going to be false. And that's going to store that value into this boolean variable here. And the next line is going to go to the animator and set the boolean for my running shoot. And it's going to pass in either this true or false here. So if the mouse is being held down, it's true, then running shoot is going to be true. If I let go of the mouse, it's going to be false, and then running shoot is going to be false. For this next bit of code, I use the for loop. So this is going to iterate through my arrays for my action array and my key code array. So it does the same thing as above. This line is saying if the button is pressed, get key down, then this true false boolean is going to be set to true, otherwise it's going to be set to false. So what that does is just fires off one time, key goes down, it fires as true, and then immediately it goes to false. And here is where we set that boolean for the action in whichever array position to either true or false. And so you see in my for loop, it goes through I equal to 0, I less than the player actions dot length. So it's going to go through that array and it will be incremented. So first time it goes through, this will be 0, this will be 0. So the map key in the first spot or the 0 position is going to trigger the animation action in the corresponding spot. And the reason I wrote this code like this is because I first had a bunch of if-else statements, then I considered a bunch of case statements. I didn't like either option, and I wanted to find a way to streamline it and make it work so that no matter what action or what key was put in, it would all work the same way. And this is what I found. My toggle works a little differently. Again, passing in the toggled actions, the toggle keys, starting with the for loop for I less than player actions dot length once again. If the input get keyed down is the map key at whatever spot in the array. So this checks which key has been pressed, and then it goes into a nested if statement, which checks if the boolean on the corresponding action is set to false. So animator get bool action in the I position equals false, it's going to set it to true. Otherwise, if it's already true, then it'll set it back to false. And of course, as this iterates through, all of these values will be the same. So map key 0 with action 0, and then switch to boolean on action 0. And the same with 1, 2, however many you put in that array. That's up for the designers to decide. Right here for my check miscellaneous player values, I created an instance of a capsule collider, and then I set it equal to the find object of type capsule collider on the player. I have a to-do statement right here to add jump capabilities in this function, where I'll be checking for jump height and gravity and things like that. But for now, here's my check if my character is in the prone position. So if that boolean on the prone parameter has been set to true, then my collider height is going to be set to 0.6 and my collider center is going to be set to 0.25 on the Y. Otherwise, my collider default values are put back in place. And here in my awake, I have my animator instance getting set to get component animator on my player or on whatever object this component is on. And I set my player current health to my player max health, and this will help me do a health bar later on with percentages between my max and my current. So I have encapsulation, I have some polymorphism, passing in my actions and my map keys, and those can be changed however the designer feels. So you can see here my player values, health, movement, speed, my action triggers, my jump values, which haven't been implemented yet, but will be used later. So I'll be doing these checks, and my miscellaneous check function, my layer mask for my mouse tracking, and then those are my capsule collider and rigid bodies. So that is about it for my project. Unnerved Assault Torrent. And this has been for my GPE340 course, Programming for Game Engines at the University of Advancing Technology. Thank you.